we are going to apply our inverses here. So like I said in the last video, when we are finding our inverse functions, we're going to go ahead and we switch our x and our y. The problem with that in application is then it kind of changes the meaning of our variables, independent versus dependent. So I want to take a look at that with an application. So a basic example, one I have to deal with quite frequently when I travel, is when people talk to me in Celsius, I don't know what that means. 22 degrees does not sound awesome, okay? 40 degrees does not, anyway. So, here we go. Fahrenheit to Celsius. So this function is, if I plug in my Fahrenheit, it's going to give me my Celsius. So, F stands for Fahrenheit, obviously, hopefully, and C for Celsius. So if I say C equals 5/9 times F minus 32. If I want to find the inverse, so say I want to go from Celsius back to Fahrenheit, which again, I need to use, I need to find the inverse function. So if I do that right now, I'm going to multiply by 9/5 to both sides. Oh wait, come on guys, help me out. Why didn't you tell me I was doing something wrong? So Celsius, we plug in the Fahrenheit, it gives me Celsius. The first thing I need to do is switch my variables. So here's F equals 5/9 C minus 32. And now I'm going to isolate that variable. I'm going to isolate Celsius. So now I'm going to multiply by 9/5. So I get 9/5 F equals C minus 32. And then I'm going to plug in, or I'm going to add 32. And I'm going to go ahead and say that's my inverse function. So if I were to use the proper notation, C inverse of F equals 9/5 F plus 32. This function will take me Celsius back to Fahrenheit. Look, I said it is my inverse. We know how inverses work. I plug in Fahrenheit, I get out Celsius. Now I'm plugging in Celsius and I'm getting out Fahrenheit. See how we have kind of an issue there with our variables? There is kind of a cool trick to help with that, especially in application cases like this. So here, this F and C, they no longer represent Celsius and Fahrenheit like we wanted to use them because we switched them, we gave them a different meaning. So to avoid that issue, we're going to start back at the beginning. So here we have Celsius equals 5/9 Fahrenheit minus 32. So what I'm going to do now to find the inverse function is I am going to isolate the new variable F. So this is plug in Fahrenheit, get out Celsius. I want to plug in Celsius and get out Fahrenheit. So what I'm going to do is I am going to isolate my other variable. I'm going to isolate the Fahrenheit so my variables stay meaningful. They keep the same definition. So here, to isolate, I'm going to multiply by my 9/5. So I get 9/5 C equals F minus 32. And then I'm going to add 32 over. So Fahrenheit equals 9/5 of the Celsius plus 32 degrees. So this function is now F of C equals 9/5 C plus 32. I'm now plugging in my Celsius, getting out my Fahrenheit. And here, I'm plugging in my Fahrenheit, getting out my Celsius. So when we're doing an application, it's almost best to just isolate the second variable to find that inverse function and then the definition of your variables stay intact. Hopefully that helps. Good luck.